All right, welcome. That's another example of an integral where we should use trig substitution, although there are folks who know how to do this potentially using u substitution, but we're going to use trig substitution. This is problem number 21 from the textbook. We're going to integrate this thing. It's a definite integral, which is useful. And actually, I can show you how to get back to x instead of changing the limits. I can go either way with that. This might be, if I do both, it's going to be a longish video, but regardless. Okay, so on the right in red, you can see kind of the mnemonic device, the thing that helps you to remember, okay, I'm going to do these, I'm going to remember this so that I know how to integrate this stuff. I have done this enough to where I just simply go, what do I need? Okay, instead of formulaically, I just go, what the heck do I need? What I need in this problem is for this 25x squared to magically turn into 9, and since it's minus x squared, I'll use the function sine squared theta. That's what I want to have happen, okay? Then I have 9 minus 9 sine squared, factor out the 9, you have 1 minus sine squared, cosine squared, and people don't like to think that way because it's a little much. So you're either looking, you want to match the coefficient, and so it factors out, and you want a 1 minus sine squared, you want a secant squared minus 1, or a 1 plus tangent squared. Those are the three things. And so, yeah, that's how I go about it. Some people use these formulas and they want to use sine. Well, you'll notice on this formula here, I think I'll use a highlighter. You notice on this formula here, right there, that is just x squared. It's not 25x squared like our problem. So to do this according to the recipe, you'd actually have to factor out a 25. And to me, it's harder that way, but if you want to do it, that's a way to go about it. Of course, the 9 turns into 9/25, etc. Regardless of how you go about it, each of us should arrive at the same substitution. Me, I simply go, you know what? I want 25x squared to be replaced with 9 sine squared theta, okay? So it looks like in this problem we have 2x squareds. There's one here, that's the x squared, but we also have the 25x squared here, all right? So for x squared, we simply go, well, all right, if 25x squared is 9 sine squared, I can simply write x squared is 9/25 sine squared, okay? So that'll take care of the x squared above, and the last thing to deal with is the dx. And that means, okay, then what I'll do for that is I'll write x is, I'm square rooting everything, 3/5 sine theta. And by the way, if you factored out the 25 and did it that way, you'd end up with this formula up here. It would tell you to use 9/5 sine theta. Great. But that also leads us to, we don't have an x, but we're looking for dx. And if we derive it, we get 3/5, derivative of sine is cosine, d theta. So we've got dx, we've got x squared, and we've got 25x squared ready to go in and be substituted into this problem. As soon as I do that, I don't write the limits anymore. I have to remember, in fact, you put a note to yourself, the limits are x equals 0 and x equals 0.6. Did I say x? Yes, x. Those are x limits right now. If you want to change them to theta limits, you can. But let's work on the problem first. So what we get with this substitution is we're looking at the integral. X squared is going to be replaced with what? 9/25 sine squared theta. Downstairs, we've got what we wanted, the square root of 9 minus 9 sine squared theta. But now the price to be paid is upstairs, and also with the dx, we're getting a 3/5 cosine theta d theta. Okay, looks horrible, looks miserable. I don't want to do it. It's okay, we got this. All right, so we've got a 3/5 going on. We got the 9/25. You know, I'd like to clean house. What I'm going to do is I'm going to take out the 9/25. I'm going to also take out the 3/5. I'm going to integrate, and what I've got is, I'll write it this way. I'll say sine squared theta cosine theta, and downstairs, watch out, square root 9 paren 1 minus sine squared theta d theta. You got to go through this because, you know, to finally settle down and see what the answer is to this problem, okay? So what we have now is, I guess you could write, all right, I got 27 over 125, right? And then I've got upstairs, I've got sine squared. Oftentimes, it's just a matter of patience walking through. Okay, underneath, I've got the square root of 9, and that turns into, this is the reason, the whole reason we're doing trig sub is that turns into a cosine squared. That's the beauty of it. Remember that. This isn't just a bunch of dance steps to try to get approved for. It's a matter of, I'm being clever, I'm using algebra and trig to make this thing happen. So finally, with maybe a step or two you might skip, but I'm not. I'm now to this point where I can say sine squared cosine divided by, and we get to square root as long as cosine's positive, we assume it is, and we square root and we get 3 cosine theta d theta. Oh, this is a glorious problem. I can see where this is going. I don't know what I'm talking about. Okay, so keep going. All right, this is pretty nuts. What we get to do, good stuff, we get to reduce it a little. We lose the cosine. And if the 3 comes out, look what happens. The 3 comes out here, but he'll cancel with 27, leaving 9. Okay, fine. That's the number game outside. And our integral is looking like this. 9 over 125 integral sine squared. Boy, I wish that were a one-liner answer, but you know what? It's not. It's not a one-liner answer. Doggone it. Okay. So what do we do in this case? Well, we have, boy, this is going to be a long one. We have to use the double angle identity on this one. So to get this far is very good. Okay, I've got this, but you're only halfway. You got to be able to integrate this guy. So the story is you have to remember the previous section, or if you're in a different book, it's the same section. And we're writing 1 over 125 integral, guess what? 1/2, since it's sine, 1 minus cosine of double theta is 2 theta. Okay, we're finally to a place where I think we can integrate. I'll bring the 1/2 out and make it 9 over 250, integrating 1 and integrating cosine 2 theta. These are elementary operations in Calc 1. Okay, I hope you agree. So we're looking at 9 over 25, 250 I should say. Integrating 1, we get theta. Integrating cosine 2 theta, who wants it? I know it goes back to sine, but there's a 2 theta in there. So there's a tiny little, as you guys know, a tiny little, let u equal 2 theta, blah, 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 and you can integrate that thing. It ends up giving you an extra 1/2. So you end up with a minus 1/2 sine 2 theta. Beautiful, wonderful, terrific. Okay, remember, it's a definite integral, so to finish it, that's what we have to do is worry about the limits. We can either change everything back into x, remember it's 0 to 0.6, or we can change the limits if you wish. This is going to be an elaborate video. I'm going to go back to x. I think a lot of people try to do that. And in all the definite integrals, you have to. So let's do it here too. So I'm not going to change the limits to theta limits, which I think is slightly easier, but instead I'm going to change back to, from theta back to x. There's a problem though. Okay, let's go all the way back up. You have to go all the way back up to one of these. Here, I'll choose this one. This is the connection. X equals 3/5 sine theta. That's the connection between x and theta. So let's write that down here. So we know that x is equal to 3/5 sine theta. Or, now here's the thing, what we're going to do is use that right triangle game, call this theta, and I'm going to fill in the sides. And this is a tricksy way of just using identities to figure out what the various trig values are in terms of x. So I'm going to write this as, I'm going to multiply 5/3, so it's going to be 5x over 3 is sine theta. Well, when we use SOHCAHTOA, we're going to use, in this case, I've done that before. We're going to use, nice and neat, SOHCAHTOA. So it's opposite over hypotenuse. So this side is going to be 5x. This side is 3 by looking at this fraction and knowing it is equal to sine. What we have to do last is use Pythagoras on this. I can do this pretty quickly. It's this side squared plus this, the 5x squared. In fact, what we end up having is equal to 9. So it ends up being 9 minus 25x squared. And that is identical to what we had in the problem at the start. See that? All right. So that's cool. So what we have then is we have everybody. We can write sine, cosine, secant, cosecant, all those guys in terms of x now, as long as, there's last problem here. I don't have sine of theta. I don't have cosine of theta. I have 2 theta. But that's okay, because look, there's another identity from Trig. I know you love Trig. And it says that what we can do is write sine 2 theta as 2 sine theta cosine theta. Are you kidding? Are we supposed to memorize all this? It's supposed to be in your blood, baby. Maybe a little bit. I maybe have a card here to help you know your identities. Anyway, there's a cancellation. And really, the last thing, well, we got to apply the limits too. This is a long video. Theta minus sine theta cosine theta. But look, we're going to replace sine of theta and we're going to replace cosine of theta. And let's do it now. So 9 over 250. And theta, it's interesting. That's weird too. Remember we had this guy and then this guy. Sine theta is equal to 5x over 3. Well, then that means that theta itself is sine inverse of 5x over 3. So that goes here. Sine inverse of 5x over 3 minus, and now what is sine and what is cosine? Well, look at sine is 5x over 3. See that guy? So we're going to go, this sine is going to turn into 5x over 3. And then we're going to work on cosine. Cosine is ca, adjacent over hypotenuse, which means it's this radical thing over 3. So we get a radical 9 minus 25x squared all over 3. And finally, we can apply 0 to 0.6. That's our goal, is to actually finally do that problem. All right, so let's do it. Now remember, look at this. 0.6 is decimal and it bugs people, but you know what else? It's also equal to 3/5. It's a cute choice by the author to do that. So we're going to plug in those limits. So 9 over 250, maybe a big giant bracket and a paren. And we're going to say sine inverse of, let's see, I don't want all that notation. Let's get rid of that thing. Sine inverse of, oh, right, Trixie. Well, it's 5/3, and then times the upper limit is 0.6, which is 3/5. Isn't that cute? And then it's minus 5/3 times 3/5, and then times radical. Okay, this is going to be 9 minus 25 times this guy squared, which is going to be 9 over 25. And then over 3, and that's just the first limit. The second limit is this, minus. Now we're going to plug in 0, and we're going to get, all right, so sine inverse of 5/3 times 0, aha, minus 5/3 times 0, correct? And who cares about the rest? It's going to be times the square root of 9 minus 25 times 0 squared all over 3. This is also, well, that's gone. And so what happens in all of this is, let's see, here's our final answer. 9 over 250. And then inside here, what is, well, I'll write it down, sine inverse of 1. And this is, look at this. Up here in red, I'm going to put a little note. Look, this guy is 1. And what happens here? All of that is 0. So it's going to be minus 0, okay, if you say so. And then minus this parentheses, sine inverse of 0, I'll write it down, sine inverse of 0, and then minus a minus. Of course, this is also 0, so it's really plus 0. And what have we got? We've got a mess. We've got 9 over 250 times sine inverse of 1. Who wants it? Sine inverse of 1, pi over 2. And then sine inverse of 0, 0. So you've got nothing but 0, and this is what you got. And it looks like I've got an answer of 9 pi over 500. Oh man, I hope it was worth it. I also hope it's correct. Okay, so yeah, obviously it takes a while to do these problems. That was a pretty elaborate one. I hope at the front end you can slow down and watch this video and make sure that it makes sense to you. But it's time to stop another recording, so see ya.